This is a fixture plate. A fixture plate can be useful for holding down parts that otherwise wouldn't work in a vise, such as thin and awkwardly shaped parts. Fixture plates feature a grid of tapped holes, allowing for a wide variety of setups. Our plates are made of aluminum, making it easy to resurface the top. An example of a part that could be placed on the fixture plate is this ME449 flywheel. I'll cover several different ways we can hold this part using the fixture plate. But first, the fixture plate and required hardware can be found in the shop drawers open to all users. You'll likely also need a dial indicator, as well as a brass hammer, which is found with the general tools. The fixture plate will mount directly into the vise. To fit, you will need to open the vise almost as far as it goes. Wipe everything clean of chips and debris before mounting the fixture plate into the vise. Pay attention to how the fixture plate is clamped onto. We want to clamp onto the actual plate rather than the attached parallels. In our hardware box, we find just about everything we'll need. First, we have bolts used to tighten our clamps, and those come in a variety of lengths. Then we have shoulder bolts used to align our parts, toe clamps that make contact with the part, Allen keys meant for the bolts we have, and a box full of shims and washers. The first setup we'll go through will be bolting directly onto the part. For this setup, we'll want to find a hole that's already on the part and just place a bolt through it. This may cause some chatter on the outer edges, however, provides a lot of clamping force and allows us to mill all the way around the outside. After tightening the bolt, we can check to make sure the part isn't going to move. For our next setup, we'll use the toe clamps found in the hardware box. We'll place the clamps in spots which don't interfere with the cutting tool or spindle. While using toe clamps, we want the extended tip to be making contact with the part. To check this, look in from eye level, and we're aiming for a slightly downward angle. One shim isn't doing the trick, so we'll add another. Looking from eye level with two shims, we can see that the very tip of the clamp is making contact with the part. This is that downward angle that we wanted. Just to see, let's add a third shim. Doing so, we can notice not much of the toe clamp is making contact. We'll go back to two shims and we'll line up so that a tapped hole is right at the edge of our clamp. We'll use a bolt in the threaded hole to apply force on the part. Note the placement of this bolt. It's as far forward towards the part as possible to maximize our leverage. After tightening, a quick wiggle check confirms the part is securely held to the plate. Now, if we wanted to hold on to a thicker part, such as the square stock, a pile of shims probably isn't the best idea. Instead, our third setup will cover using bolts as the fulcrum. Doing so is as easy as threading the bolt into the hole found on the back of the toe clamp. Having the head of the bolt make contact with the fixture plate will distribute some of the pressure and prevent unnecessary marring of the plate surface. To further prevent this, we'll place the bolt head on top of a shim. And just like before, we want to check that the clamp is at the proper angle. Aligning our clamp with one of the threaded holes, we can bolt down the clamp, securing the part. When complete, here's what it should look like. Here I repeated the same thing on the other side and will now show you how to use the shoulder bolts to align your part. The shoulder bolts will screw into the threaded holes on the fixture plate. These bolts provide a precision surface that a flat edge of your part can be bumped up against. I'll loosen up these clamps to bump the part up against the shoulder bolts. You may need to adjust or relocate your clamps using this method. After securing the part and tightening the clamps, we can remove the shoulder bolts. With our clamps just tighter than finger tight, we'll use the dial indicator to ensure our part is square. This process will be very similar to indicating a vise. Starting on one end of the part, move the y-axis to bring the indicator to 0. Run along the x-axis and watch the indicator fluctuate away from 0. In this case, the part is running towards us, so using a brass hammer, we'll tap the part to bring the indicator back to 0. Repeat this process until the indicator only fluctuates a few dashes. Then tighten the clamps to your desired clamping force and complete one final check. This part is within a thou, so we're all set to go. If you use a CNC program, be sure to check for clearance before hitting run. Start by bringing the tool right above the height of the clamps and perform a dry run to prevent crashes. Note, anytime the DRO says check Z, it is about to move rapidly, therefore lift the quill. Slowly watching the end mill through this program confirms we're all set to run. Often we'll cut incrementing the Z-axis by about 30 thou each pass. And on the final pass, we can take a light skim cut out of the fixture plate. Doing so gives us a nice finish all the way around the contour. You'll notice that we left a few burrs on the fixture plate that will prevent the next part from sitting flush. To clean them up, just run a file across the top of the surface until it feels smooth.